Good day to you and welcome to Cujo Sound. Bjørn Jacobsen coming at you right here from the Cujo Sound studio in Copenhagen. After a while with game audio talk and deciphering other video games, it's now time for me to talk about how I actually solve things. Have in mind that this is not a video showing you how things must be done. It's a creative help for you to iterate upon in case you want to create similar tools or solutions, or you want to talk to your programmer about how you want things to be done. As always, I'm not a programmer and I don't consider myself any good at scripting. It's black magic to me. So I will always approach scripting and coding from a sound designer's perspective and explain stuff super low level and to the best of my ability try to make it as relevant as possible to you as a sound designer and not try to talk about all sorts of gizmos and fancy stuff that isn't helping us. All I care about is how I can make a sound play and behave the way I want it to do. This video is about Unity and I'm trying to create some sort of area. An ambient area, a defined area in which a sound can move around with the character as you enter it, and when you leave it, it will act as a normal 3D sound. It's the first step towards creating some sort of gating control system so that ambient sounds will come from a direction but spread out around you and act as a 2D sound when you're in the defined area. It's different from just placing a 3D emitter and set it to full spread, and we'll get to that as we go over the tool. To begin with, we just want a box collider that a sound can move around in, but stick to the walls of the collider as we leave it. If this is out in open space and you can enter it from all sides, it's basically just the same as a 3D sound that spreads. But the point is to place it in areas where you can only enter or exit from specific places. This will force the emitter to come from that opening as you can enter and exit from, without much black magic going on, and it will make it seeming like the sound will bleed through the different areas that you set up. So first things first, I want to create a box collider, in which an audio source, as it's called in Unity's position, should follow the player when he's inside the box collider, and as we leave the box collider, it should still follow the player but not exceed the borders of the box collider. I want this to be a prefab so that you can always use it on any level in whatever game you're working on, and it should automatically work right out of the box. Okay, so first things second. Okay, I have loaded this free level that I found in the asset store called the UI models. Props to the people involved in making this, and I've loaded the Invector third-person controller. Also props to the people who made that one. Both are free in the Unity asset store. I've done a couple of modifications. I moved the camera manually to be behind the character. I've deleted the audio listener from the camera and placed it on the third-person controller game object. The reason for this is because this prevents the problem I mentioned earlier in one of my game audio talk videos about Detroit Become Human, where a third-person controlled environment can rotate the camera and in some cases force the camera to be outside of the area where you as a player are in, which causes some unwanted effects. So I moved the camera to the character so that all calculations and measuring are done from there. This gives us a bunch of things to solve later, but we'll get to that in future videos. First, let's create an empty game object, which we'll name accordingly amp_ambient area. This is because I, and you should as well, try to stick to a naming convention from the very start. And later we can name all things related to ambient as amp_, and then whatever object it is and what it's supposed to be controlling. And in this case, it's an ambient area. We create an empty game object as a child of this object and call it emitter. This is where we'll store our actual audio source component. Why isn't the audio source just placed on the main game object amp_ambient area? This is simply because we need to move some of the values in either object's transform position, and if the audio source is located on the box collider, then the collider will move with the audio source, and we don't want that. We only want the audio source to move and not the collider. Let's create a script that controls all of this. This is where it gets hairy and almost like black magic to me, and be in no doubt that this took me quite a long time to figure out how to do this on my own. It was good training though. We'll name the script audio position. We also need to attach a box collider component to our main game object and an audio source component to our emitter object just beneath the other one. Now that this is done, let's make this into a prefab so that we can use this over and over again all over our level. We do that by dragging the parent game object, in this case our amp_ambient area object, into the project folder under assets. This will create a prefab of whatever we dragged in, And you will know this by seeing it being represented by this little blue box icon here in the assets folder, and now also in the hierarchy up here as blue text. So just to be clear, I want to be able to press play and play the level, and I want to be able to run into this collider's area, and I want the emitter to follow me around. When I'm outside of the collider, I want the emitter to follow me still, but only within the collider's boundaries, just like you see right here. Let's open our currently empty script audio position here, just to make sure that this script cannot load on an object without a box collider. The first thing we add to the line is a require component type of box collider on top of the public class. This makes sure that if you load the script on any item, it will automatically load a box collider onto it as well. First, we need to define a number of few things, such as what is our emitter, what is our audio listener, what is relative to what, and where in the world are all these things located. Let's start by making sure we have an audio source that we can control. So we add the line private audio source audio emitter into our public class. This means that we now can control an audio source, and it's called audio emitter in the script. We could have named it anything else, or we could have named it whatever we wanted, but I like to name everything that emits a sound as an emitter, so audio emitter it is. But we haven't yet defined where this audio source actually is, and to make sure that our script knows what we're talking about, then down here in our void start method, we define that audio emitter, remember that this is what we called our audio source, so our audio emitter equals get component in children audio source. This means that the code will scan all children of this object we're dealing with and locate all audio sources. Because we know for a fact that there will only be one audio source, or at least for now, we can do it like this. Ask any programmer and they will tell you that the get component call is pretty expensive. So defining a variable like our audio emitter like this means that we only need to run this get component call once and not every time we need it. And that is apparently good practice. We also need to know where our audio source is in the physical world. We do so by adding a private vector3 emitter position to our script. A vector3 is a coordinate system with 3 values, x, y, and z. This defines where in the game world anything is. We also need to define the values of the emitter position variable. So again, in our void start method, just under our audio emitter definition, we define that emitter position equals audio emitter transform position. The transform position is what you will see here in the very basics of Unity. Any object will have such a value when it's located anywhere in the game world. Don't be fooled right now because it says our emitter is in 0.00, but that's just its local position relative to the main object's location. That'll work differently when we start changing these values, and we'll get to that in a jiffy. We also need to define where the listener is. To do that, we need to define which game object it is on. In this case, we know that it is an object called third-person controller. So we can create a private game object character and a private audio listener. We define that character equals game object find third-person controller. This will look for any game object called third-person controller, and there can only be one of those. And that listener equals the character get component audio listener. In that way, just like before, we have checked for where our needed component is, and we don't need to look for it anymore. We can also just talk to our variable called listener, and we know that it represents our audio listener. Because as before, checking with the get component call all the time is expensive and unnecessary. And finally, for the last physical objects we need before we get started is that we need to define which collider we're going to use. By adding a private box collider ambient collider to our list of variables, we define it as an ambient collider like get component collider. When you just write get component like that, without anything before it, the script automatically assumes that we're talking about the current object. And in this case it's fine, because our script is on the same object as our collider. Now it is time for us to figure out the size of our collider and determine that this is the area in which our emitter can move. We need to store the value of our listener's position so we can declare a private vector3 listening position. And this value is different from the other ones that we defined with the script loaded, as we only needed those values defined once. These values need to be defined all the time, so we need to go down into our void update method and write that our listener position equals the listener's transform position. The void update section here is the code that is run on every frame so that it changes this value on every frame. As you might remember, then listener was defined as our audio listener. This is very important that this is defined as the very first thing in our void update method, because if this value is updated after the calculations, it simply won't work and we'll get a lot of errors saying that the value is null. Null means nothing. Not zero or something else, it's just nothing. Nothing. So basically we could now say that audio emitter's transform position equals listener position. If we do that, the emitter will constantly follow us around where the listener is. But remember that this is not what we want. We only wanted to do so when we're inside the collider's area. So that line of code, audio emitter transform position equals listener position, needs to be only called when we're inside the collider. First we need to make sure how big our collider actually is. I've done this in a very simple way, and in this way it only works if all sides of the collider are equally big. If you try to build this and you want an uneven sized collider, you just gotta do the math differently. Anyway, I've created two variables as a vector 3, called collider size max and collider size minimum. In our void start method, we define that collider size, both min and maximum, equals ambient collider's transform position. This means that we first define that collider size, both minimum and max, are equal to the position of the collider in the world. Then if we want to make our collider bigger by pulling on the sides like this, notice how this value scale becomes bigger or smaller here in our inspector view. I've set it to 5 now manually, meaning that it's 5 meters or units across, not on both sides, but in total. So we do the following math. Collider size minimum and maximum plus equals transform the local scale divided by 2. Plus equal or minus equal means that if you take a value, you add or deduct something from it, but the new value is stored in the same variable name. So collider size max plus equal transform local scale divided by 2 means that the value of variable collider size max is now itself plus the scaled value divided by 2. In that way, we know exactly the top values of our collider's 3 coordinates. The same thing goes with the collider's size minimum, that you say minus equal transform scale divided by 2, and in that way we know the minimum size of our collider. All that is left now to do is that we need to store the 3 values of our emitter coordinates individually. So we create a float emitter x, a float emitter y, and a float emitter z, and a boolean value that can define if we're inside or not of the collider. So a private bool is an area, and it must be false when we start the game. Now here comes a lot of if statements defining if we are within the boundaries of the collider or not, and what happens to the values if we are either. An if statement is what it is in English. If something, then something happens, or if not, then something else happens, or nothing happens. An if statement can be written like this: if, and then what needs to be checked, and then in the curly brackets you write then what happens, if what you just wrote in the parentheses is true. In other words, if listener position's x coordinate is bigger than the collider size minimum's x coordinate, and the listener position's x coordinate is smaller than the collider size max x coordinate, then emitter x becomes equal to listener position.x. The and signal here means and, meaning that both sides of this needs to be true before we execute what's happening. So if the x coordinate in the listener position is bigger than collider size minimum's value and smaller than the collider size max's value, our variable emitter x grabs the value of our listener. Now this also means that we need to tell it what happens if we are outside of the minimum and maximum values set. So we need 2 more of these if statements. If listener position's x coordinate is smaller than collider size minimum, then emitter x equals collider size minimum x value. And if listener position x is bigger than collider size max, then emitter x equals collider size max x. This means that if our listener is inside the x coordinate limits of the collider, then the emitter follows our listener along the x-axis. If we are outside of it on either side of the minimum or maximum values, the value cannot exceed the minimum or maximum value. We do this for all 3 coordinates. This means that we have now established the values of our three emitters X, Y, and Z. And this is where our Boolean value is an area comes in handy, because in our void update we make an if statement saying that if is an area is false, then audio emitters transform position gets a new value in form of vector 3 with the three coordinates emitter X, emitter Y, and emitter Z. This means that if is an area is false. That is what the asterisk in front of it means. Our audio emitter's position in the world becomes equal to these values. They must be written in that order, else the script will just use the wrong numbers in the wrong place. This obviously means that we need to set our is an area Boolean value to true if we are actually inside the collider. So we create a new method called void ontriggerstay collider other. And then something happens within these curly brackets. This is almost like the if statement from before, that whatever is written within the curly bracket happens when we are inside the collider. You can also create a void ontriggerenter or an ontriggerexit collider other. These are only called once when you enter or exit the collider, and we only need to know when we exit the collider because we already know if we're inside the collider with the ontriggerstay. Let's tell it what happens if we are inside the collider. Void ontriggerstay collider other, and I have actually no idea why you have to call it other, but it's just there. If is an area is false, then is an area becomes true, and audio emitter's transform position becomes our listener's position. First, if is an area is false, it becomes true. That means that our statement from before about our emitter having the position given by the three variables that we stored will no longer run. Instead, our emitter position will now become the same as our listener's position in full. We add a private void ontriggerexit collider other, which makes sure that when we leave this collider, is an area becomes false again. This is to make sure that is an area becomes false once we leave the area, and that is to make sure that the right piece of code is run again when we're outside of the collider. Now we can run around the collider like this, and you will see here in the game view on the right and in the scene view on the left that the emitter moves along the collider as we want it, but once we enter the collider, it follows us. Why is this useful? Well, in our audio source here, we can set the max distance and the spread and volume curves. This basically represents the distance from when we are outside of the collider, which could be considered our ambience bleed distance from whenever this sound is being played. But take a look here. If we place our prefab inside this room here, then it's only possible to enter the room from this door here, meaning that if we approach the door, the sound of the interior ambient sound will now play from a location seemingly coming from the door in the distance that we have set from the audio source. Especially if you have a level where you have easy control over where your player will enter or exit a specific room, then this is very useful. In a future video after this one, let's expand on this script and try to make it into some actual gates with unique values per gates and control where the sound can be heard from and going to and where it cannot be heard. Combine that with some occlusion and other things and we'll have a pretty hefty and controlled audio setup. Thank you for watching, and I hope you enjoyed it. And if you have any questions regarding the script, or if you just didn't catch any specific part of what I just said, fire away in the comments below and I'll answer. And you can always find this script on cujo.dk/scripts. While you're at it, and if you like this video, then why not hit the like button? And if you just more than liked it, why not hit the subscribe button now that you're at it for a steady flow of videos on game audio? Maybe even check out my channel for all the previous videos that I did. Perhaps check out that Detroit Become Human video, which explains some of the issues about having the listener on the camera or having it on the character. If you totally dig this and want to learn more, why not jump over to patreon.com/Cujo Sound, where you for as little as $1 a month can help me sustain this channel and afford the time that I take out of my spare time to create all this content. I would really appreciate it. On patreon.com/Cujo Sound, you will also find all of my previous material. But by signing up, you also gain access to a dedicated Discord channel, counseling, supervision, help with your project, and more. And you're helping a fellow sound designer out, so what do you say? Cujo Sound and Bjørn Jacobsen, signing out.